Hello friends, welcome to the class of marketing research and analysis. So, we were continuing from the, we will be continuing from the last lecture where we had discussed about hierarchical regression, and then we also discussed about dummy variable regression. So, a concept which is very helpful when you have your independent variable as a categorical one, right. Today we will be discussing about a new technique which is also slightly different in nature from the usually discussed regression methods, right. As you know that in regression, when you talk about regression, the dependent and the independent variable, they need to be continuous in nature, right. So, when we had a case of a independent variable not being in a continuous, but in a categorical variable, there we talked about the role of dummy variable coding and the dummy variable regression. But what if our outcome or the dependent variable is a non-continuous or a categorical variable. So, a condition which is violating the general assumption of regression, right, since regression usually says they both have to be continuous, dependent as well as the independent. But here we are saying that we do not have a dependent variable which is continuous, but it is a categorical variable. So, in such a condition what can we do? So, there are two techniques which we will be discussing in this lecture and the next lecture. So, one is called the logistic regression, right, and the other is called the discriminant analysis, right. So, logistic regression is one technique where the outcome variable or the dependent variable is actually not a continuous variable, but a categorical variable, and the independent variables or the predictors are all in continuous in nature, right. So, there also you can have both continuous as well as categorical, right, but generally the general assumption is the predictor is continuous and the outcome is non-continuous. So, let us start with it. So, what it says, logistic regression extends the ideas of linear regression to the situation where the dependent variable y is categorical, correct. A categorical variable as divides the observation into classes. Basically what a categorical variable does, for example, let us see, if y denotes a recommendation on holding or selling or purchasing a stock, then we have a categorical variable, that means with 3 categories. Okay. For example, make it more simpler, you want to know about the income category of people, let us say income. So, you have 3 income categories, high, medium and low. So, these are the 3 different classes we are talking about, right. So, in this case each of the stocks in the data set as belonging to one of the 3 classes, right, the hold class, the sell class and the buy class. Logistic regression does not face, the one good thing about logistic regression is that why it should be used, it does not have a very strict assumptions of multivariate normality and equality of variance among groups. So, the good thing about logistic regression is that when I will talk about discriminant, the difference between logistic and discriminant is that in discriminant you need to be your data should be following all the assumptions of a multivariate of normality, right. But logistic regression is does not follow very strictly all these assumptions, and it can work better when your data does not follow this all these assumptions, right, of normality, homogeneity of variance and etc. So, as it says, logistic regression extends the idea of linear regression, right. So, which where the y is categorical, we have already discussed. So, it is used in applications such as where, let us what are the applications. First is to classify the customers as returning or non-returning. For example, a bank classifies whether the person after let us say giving some kind of a service or some kind of a benefit, are they again coming back to the bank or they are not coming back to the bank, or let us say a company wants to see whether after giving a sales promotion whether the customers are returning back to the company or they are not coming back to the company, right. So, in such a condition it helps to classify it, right. Finding factors that differentiate between male and female top executives, so profiling. So, sometimes you need to understand what are the differences between the male and female top executives. So, you are profiling the factors, right, which helps in differentiating them. The third, for example, another classification method, predicting the approval or disapproval of a loan. So, suppose there is a person who has come for a loan, should you approve the loan or should you disapprove the loan? Now, on what basis will you do? based on some information such as credit scores, which may be based on your income, your past performance, your let us say age, your stay, where you stay, right, your ownership of property, etc., right. So, we deal only with a binary dependent variable having two possible classes. So, generally we will talk about the binary logistic regression, right, binary logistic regression, which is the logistic regression we are talking about. So, generally when we talk about logistic regression, we talk about the binary logistic, although there is another method called the multinomial logistic regression, but we are not talking about it. The only difference is that the besides the binary and the multinomial, that in the multinomial you have more than 2 levels instead of 0 and 1. Let us say, as I said about high, medium, low. So, there were 3 classes, right. So, there it is a multinomial logistic, but suppose you have only 2 classes, approval or rejection of a loan, for example, entry to a college, or disqualifying the candidate. So, such kind of cases where there are only 2 options, we will use a binary logistic. When you have more than 2 options, you will have the multinomial logistic. Okay. So, for example, let us see some cases. Success, failure, y can assume 2 values, one is success, failure, buy, do not buy, defaulter, not a defaulter, will the patient survive or will he die. Now, there are only 2 options, either he will survive or he will die, there cannot be a third option, right. So, you may include a third option, like for example, somebody would say coma, but then also that is a survival. So, we quote the values of y as 0 and 1. So, anything you can take 0 and anything you can take 1. So, suppose I take failure as 0 and success as 1, it does not matter, or if I take success as 0 or failure as 1, it does not matter, right. We may choose to convert, sometimes you can also do with some continuous data. For example, let us say you have a data where the original income of people is known to you, right. So, for tax, for example, the government for tax benefits, so what it does is it has divided the people into different income brackets, right. So, bracket A is somebody, maybe I am just giving an example, above let us say 10 lakhs per month, bracket B is somebody from 5 lakhs to 10 lakhs, or bracket C is somebody in between 0 to 5 lakhs. So, this is like 3 different classes being made, right. So, 1, 2, 3. So, right. So, you can convert continuous data also into such categories and run a logistic regression, right. The independent variables may be categorical, but we generally talk about continuous variables, right, because that is the general property of a regression model or regression equation, right. Or you can have both, right, because now by this time you have already learnt about dummy variable regression, you have learnt about simple regression, and you are today learning about logistic regression. So, when you take, you can understand that it can take any variable, that means any kind of value, be it continuous or be it categorical. In multiple regression, the aim is to predict the value of the continuous y for a new observation, that is what we were doing, right. But in logistic regression, the goal is to predict which class a new observation will belong to, or simply to classify the observation into one of the classes. So, here you there in the normal regression, what you are doing, you are measuring the y on basis of a certain value of x after calculating for a and b. So, when x was changing, what is the new value of y you are trying to find out, but here you are not doing that. What in the regression equation you are doing, since you have only 2 options 0 and 1. So, on basis of this values, you will only say whether the person will fall into this category 0 or will it fall into this category, that is what we are trying to find. So, the logit model or log odds ratio or logit is given as this is the formula how you understand it is given, right. So, log of p divided by 1 minus p, right. What is this p? P is the probability, it says p is the probability that the event will occur, y occurs, right. So, log of p by 1 minus p is equal to what? Now, b 0, so that means what? Your initial intercept plus slope 1 b 1 x 1, sorry, this should be x 1 plus b 2 x 2, right, goes on plus b n x n, right. So, this is the formula, and this ranges from minus infinity to plus infinity. Okay. P is the probability that the event will occur, and p is given as, you can see this, p is given as p is equal to 1 by 1 plus e to the power minus b 0 b 1 x 1 b 2 x 2 up to whatever b n x n, right. and obviously as you know, the value of a probability lies between 0 and 1. So, this is maximum it will lie. P by 1 minus P, this part right, is called as the odds ratio, right, where P by 1 minus P is equal to odds is given as, this is the formula. So, just you note down this formula, you remember this formula. So, so here we are using P is equal to 1 by, if you see, 1 plus e to the power minus b 0 plus. So, minus the odds, right, 1 by 1 plus e to the power minus odds, right. So, note the estimated probability is P is equal to 1 by 1 plus exponential minus alpha minus beta x. So, this is what you are saying, minus alpha minus beta x, right. So, now using this formula we will try to find out, right. So, logistic regression thus forms a predictor variable of log P by 1 minus P, because a logarithmic value which is a linear combination of the explanatory variables, the predictor variables. The values of these predictor variables are then transformed into probabilities by a logistic function, right. We will show this function, probabilistic function, it is a probabilistic function. So, it lies between 0 and 1. So, what happens, I will show you in the next slide maybe. So, let us look at this. If you see, if I take this, the probabilities are taken in between 0 and 1, right, and the values of the log, this value, right, you see this. On the horizontal axis we have the values of the predictor variable, horizontal axis the predictor variable. So, these are all the predictor variables, right, predictor variables, right, and on the vertical axis you have the probabilities. So, this is the probabilities, right. So, when I draw and I plot the values. So, all the values will lie between 0 and 1. Why? Because the probability maximum ranges from 0 and 1. So, that is why when you plot the different estimates, right, after iteration. So, interestingly you should know that logistic regression does not follow a method of least square, right, a method of least square, it does not follow it. Why? Because here there is no point of finding out the variance from the regression line, right, you do not have any value. So, what you do is basically you follow in the case of a logistic regression, you are following a maximum likelihood method, maximum likelihood method. Why it is called a maximum likelihood method? Because it says what is the maximum chance of an event to occur, right. So, this is termed, this value is given through the probability, right. So, what is the probability is the chance of occurring, right. So, what is the maximum probability of occurrence, okay. So, when we do this, it gives a S shaped, if you connect the dots, right, the values of these probability values, you will see that it gives you a S shaped curve called the sigmoid curve, right, the sigmoid curve, okay. So, this is what I was talking about, the S curve or the sigmoid curve, right, okay. Now, what is this odds ratio in the logistic regression? Let us understand it very clearly. The odds of an event is defined as the probability of the outcome event occurring divided by the probability of the event not occurring, simple. The probability of the outcome event occurring divided by the probability of the event not occurring. So, odds are usually written as, for example, 5 to 1 odds. What does it mean? Which is equivalent to that every 5 times, in every 5 times there is only one chance that you might get it or not get it. You see 1 out of 5 or 0.2 or 20% chance. That means, in every 5 times that I will, let us say, toss a coin, the chance that I will get a head is only one time, let us say, right. So, then I will say what is the probability? This is only 20% chance or 20% probability, okay. If there is a 75% chance that it will rain tomorrow, then 3 out of 4 times we say that it will rain, correct, because 75 is 3 times out of 4, right. This means that for every 3 times it rains, once it will not, right. So, the odds of it raining tomorrow are 3 to 1, correct. This can be understood as 3 by 4 divided by 1 by 4, this is not happening, this is happening, is equal to 3 by 1 is equal to 3. If the odds that my pony, my horse will win the race is 1 to 3, that means what? For every 4 races it runs, it will win once and lose 3. So, this is what it means. Odds means what is the chance of something happening, the probability of the event occurring by not occurring, right. So, some of the assumptions of the logistic regression now. What are the assumptions? Your dependent variable should be measured on a dichotomous scale. you know about it, right. Second assumption, now for example, yes, no, extrovert, introvert, obese, not obese, given some examples. One or more independent variables which can be either continuous or categorical. So, that also we have explained. Explains example of continuous variables include revision time, intelligence, performance in the exam, etc. And ordinal variables include Likert items also which can be taken, right. Third assumption, independence of observations. Again I have repeated it several times, where the observation or the respondent is taken once and only once, right, until and unless this is a study for repeated measure study. There needs to be a linear relationship between any continuous independent variable and the logic transformation of the dependent variable. So, what it says, there has to be a linear relationship between any continuous independent variables, right, or you take, so any predictor variable, right, x1, x2, and the logic transformation of the dependent variable. So, the logic transformation that you make, there has to be a linear relationship between this and this value, right. So, but remember, the best part is that the best thing about logistic regression is that logistic regression is not, does not follow strictly, if your data violates the normality assumptions, then in that case you can very well use a logistic regression, but in such conditions its alternative, for example, the discriminant analysis which I will be explaining in the next class, will not be applicable, right. Okay. Let us take a case. A researcher wants to know whether the credit card default can be predicted. Every company wants to know, can we predict a defaulter or not, based on monthly salary and gender, right. So, the researcher recruited 159 participants to gather the data, right. The participants were evaluated for the presence of credit card default. So, gender, female is equal to 0, male is equal to 1, and default, if somebody has defaulted, is 1, no default 0, were coded into the data sheet. A binomial logistic regression was then run to determine whether the credit card default could be predicted from their monthly salary and gender. So, such a situation you must have also, you also have faced in life. I want to know whether I would be can I get a admission into some university in London or some university in US on basis of my scores and some of my other characteristics such as my age, my past record in my school days and all. So, I am interested. Okay. So, how do you do this in SPSS? I will show you, but let us just have a glance at it. When I go to analyze, you go to regression. In regression you see this binary logistic, sorry, and there is also a multinomial logistic, but I am just talking about the binary logistic, this one, right. Then what I do is I take my credit card default into my dependent variable, right. So, in logistic regression I am taking as a dependent variable credit card default as a dependent variable and monthly salary which this one, and my gender as my covariates, right. But you remember that gender is a categorical and monthly salary is continuous. Okay. So, what I am doing is now I will do one thing, I will take this if you okay. So, I can take this into this categorical variable, right. So, categorical covariates, it has a function, logistic regression has a function to to explain whether your covariate is categorical or continuous in nature. So, whether your covariate is categorical or continuous in nature, it provides you a space for that. Now, once you have done it, right, then this is what you get in the options. So, there is an options, right, if you go to this option, right. So, when you go to options you get this, right, and here I will show you. Now, let me go to the main slide and I will show you the data. Now, this is the exact data we are talking about. So, we know, let us go to the variable view. So, credit card defaulter. So, let us see what is this. Now, if it is a defaulter then yes, if it is not a defaulter then no, there is no default then no 0 and yes is a defaulter 1, let us say. Similarly, let us go to monthly salary. So, there is nothing to talk about monthly salary. Gender, what is it? Now, 0 is female, 1 is male. Okay. So, okay. So, you have got your values. Now, let us run a binary logistic regression, right. So, let us go to regression first and go to binary logistic. So, what is the dependent variable? I want to know whether my credit card default, whether the person who is coming new, whether he will be a defaulter or not a defaulter. So, I am taking it as a dependent variable, right. So, what are my covariates? These two are my covariates. Okay. So, now I go to this one categorical. Now, you see, is there a categorical covariate? Now, yes, I do have a categorical covariate. Which one? Now, gender, right, because it is categorical 0 and 1, male and female. Now, I am saying continuous. Okay, here it is interesting, you see reference category, it tells you something about a reference category. Can you see this? Now, this reference category, there are two options, last and first. So, if you see, now in our case, suppose for example, you want to compare against what? Suppose for example, male and female. Now, let us say my reference category is let us say female, and female is let us say 0, right, that is what we had done. Let us go back, okay, let us go back and see variable preview. So, female is 0, right, and male is 1, right. So, you remember this. Now, let us go back. So, analyze regression. So, binary, and this is this, this is this, this is here categorical. So, I am taking my categorical here, and so what I am doing is, since first I am female, I am comparing the female and the male, I am taking the reference category as the female, and male is my the other one which is has a value of 1. So, I take the first one, the first is the male which is 1, right, and I am taking as and comparing it, right. So, now after this I go to options, what I need is this value, right, the goodness of fit, and then I need the classification plots, I need the case wise listing of residuals, I need confidence interval for exponential, right, and this is all I require. Now, let us run it. So, as you see look at the gender. Now, female 67 and male 92 cases are there. Now, if you look at how many people have done credit default, right. So, beginning the first step, right, default, it was observed that there is no default, and what is predicted, this is observed and this is predicted. So, how did the model predict? No, no. So, there will be no default and there is no default 141, right. No default and yes. So, now overall percentage is saying, suppose you see people were predicted that they would make a default, but they did not make a default is 18 cases. So, the actually the model's accuracy rate is now, so because it has been because of this 18, now it has come down to 88.7 percentage. Okay. Now, let us look at this. So, once we have got these values, so we when you look at the output, this table, the variance, the model summary is important for us. Now, let us go to the output file again. So, as you go down, this is the model summary I was talking about, I was searching for this. So, if you look at this model summary, right. So, this 2 log likelihood or 2LL, it is called as minus 2LL, and the Cox and Snell R square Nagel. So, these are called pseudo R squares, right. They are nothing but your normally it is like your normal R square, right, and it ranges from 0.17 to 0.335, right. So, this value is basically talks about like any normal regression equation, like you have a R square, this is similar to that R square value, right. And then let us go back and look at this. So, this table now, for example, this value, right, if you look at the same value we are getting here, right. So, it contains the Cox and Snell R square and the Nagel square R square value, which are both methods of calculating the explained variance like in the regression equation R square, right. These values are sometimes referred to as pseudo R square values, right, and however, they are interpreted in the same manner, but with some caution, right. So, what it says, therefore, the explained variation in the dependent variable based on our model ranges from how much 17% to 33.5%, right. So, depending on whether you reference, you can refer any one, but the Nagelkar one is much better, right, is more preferred in comparison to the Cox and Snell R square, right. So, R square Nagelkar R square is a modification of the Cox and Snell R square only, and the latter of which cannot achieve value of 1, right. So, what it says, this one, the Cox and Snell will never achieve a value of 1, right. For this reason it is preferable to report the R square Nagel square R square value. Why it does not reach a value of 1, there is a reason behind it also. The scale used are for the Cox and Snell and the Nagelkar are different actually. So, that is the basic reason why the Cox and Snell value will always be lesser than the Nagelkar R square value, right. So, that is why it is a modified Cox and Snell R square only. Okay. Now, how do we interpret this? So, as we see, we did a binomial logistic regression, right. The probability of an event, in this case the credit default, right, occurring, we try to check it. So, if the estimated probability of the event occurring is greater than or equal to 0.5, right, SPSS or any software classifies the event as occurring. Credit card default, yes. Suppose it is more than 0.5, then it is yes, right. If it is less than 0.5, it is no, right. First, notice that the table has a subscript, this one, which states the cutoff value is 0.5, right. This means that if the probability of a case being classified into the yes category is greater than the 0.5, then that particular case is classified into yes, right. Otherwise, the case is classified as in the no category. You do not have to understand, just remember, if what it says is to understand that how it takes 1 or 0. If it is more than 0.5, then it is, if it is even 0.55, then it is a yes category. If it is even 0.49, it is a no category. That is what, and this is maybe you can say is a drawback, because the logic is cannot be applied. Sometimes in real life we may have to think that 0.49 is as good as 5, but then statistically this is not possible, and this is the demerit sometimes of mathematics or statistics, you can say, right. The variables in the equation table shows the contribution of each independent variable. Now, let us go back to our data set. So, right. So, let us look at this is the model summary you saw, right. So, this is actually this Hosmer-Lemeshow test is nothing but similar to a chi-square test, and it should be significant. That means the model is significant. It talks about the goodness of fit. That means what? It says that the variables are fitting well to explain the model or the dependent variable. Okay. Now let us go to this one, right. Now, classification table, two tables which are important. One is the classification table, and here you see the cutoff value is 0.5, right. So, in the case where the observed variable was no, that means there was no default, credit default, and the predicted value was also no, it is a case of 140 people. So, which is no problem, correct. But the observed value was that the person will not be a defaulter, but in real life it became in real life it is not a defaulter, but the equation predicted that it will be a defaulter is only one case, right. So, the observed is he is actually a defaulter, but what happened in the during prediction, you found that it was assumed that they will not be a defaulter. So, there are 13 cases. So, 13 cases were assumed that they will not be defaulters, but they actually became defaulters. So, this is a mistake of the technique in our weakness in our technique, and there are 5 cases which was observed that they would default and they actually defaulted 5. So, taking this overall the percentage when you measured, it said that the model is giving a 91.2 percentage, right. So, 91.2 which is the overall model's strength. Now, look at these two independent variables, monthly salary and gender. Now, if you see this helps you from here, you can find out from the significance that monthly salary is significant at a higher level and gender is also significant. That means what? From here we can say that monthly salary does predict whether a person will be a defaulter or not a defaulter. Similarly, gender also predicts whether a person will be defaulter or not defaulter. Okay. Now, let us go back to our slide and you see the Wald test, the Wald column is used to determine the statistical significance we just saw for each of the independent variables, and from the significance column you can see that gender had a p is equal to 0.004 and monthly salary 0.000 added significantly to the model to predict the model. Okay. Now, how am I reporting this? A logistic regression was performed to ascertain the effects of gender and monthly salary on the likelihood, right. So, remember again this word likely, maximum likelihood, it is a, because it is a probabilistic model, it is not a method of least square, right, which is generally you follow in the multiple regression. That participants were going to default on their credit card payments. The logistic regression model was statistically significant. The chi-square, the chi-square value which you saw, which said about this, right, was significant at 0.003. The model explained 33.5% the Nagelkar R square I am assuming here, taking here, of the variance in the credit card default, and correctly classified 91.2% of the cases. Decreasing salary was associated with an increased likelihood of credit card payment default, and it was observed that men tended to default more than women, right. So, these were some of the, this is how you write the output, right. So, I hope you are clear that logistic regression is a very interesting, very important way of understanding to do a regression when your dependent variable or outcome variable is in a dichotomous mode or in a binary mode, right. So, in such condition you can use logistic regression to predict whether the outcome will happen or not happen, right. So, similarly in the next lecture I will talk about another technique called the discriminant analysis, which is similar to this, but there are slight differences which I will explain in the next class. Thank you so much.